Wait for it to start recording. Okay, there we go. Okay, so secants, tangents, and angles. So today we're going to review some of the words we've already seen before, like arc, chord. We're going to get into secants, and we've seen tangents before. So here is just a quick overview of what these terms mean. So a chord is a segment with both endpoints on the circle. So if we have a chord, it runs through the circle and it meets at opposite ends. So it meets on the circle, on the outer part of the circle, at both ends. A secant, on the other hand, is a line or ray that intersects the circle at exactly 2 points. So basically the secant would be this line right here, and it runs through the circle. So it runs past the circle, but it does intersect at 2 and exactly 2 points. Okay, so that's a secant. And then a tangent, we've seen this. It's basically a line or line segment or ray that intersects a circle at exactly 1 point and contains no points on the inside. So it would run on the outside of the circle, and it does intersect at 1 point, which is our point of tangent C, but it only does that at on the outer part of the circle. It doesn't necessarily go inside the circle. And then lastly, we have central angle, which is basically an angle that is inside a circle and has its vertex at the center of the circle. So its vertex would be here at the center. And then both of its sides would be the radius. So radius runs from the center to the outer part of the circle, from the center to the outer part. So both of its sides are the radii of the circle. Okay. Any questions about any of these terms? So we have chords, secants, tangents, and central angle. Okay. Okay, so let's go ahead and dive into one of the theorems we're going to look at today. We're going to look at two theorems, but here's the first one. This is the angle formed by two chords theorem. So again, we saw a chord basically runs from one side of the circle to the other side of the circle. So here would be one chord, A to D would be one chord, and C to G in this example would be another chord. Okay, so it says if two chords intersect within a circle, so on the inside of the circle like we see here, then the measure of each pair of vertical angles formed is equal to 1/2 the sum of the measure of their intercepted angles. So basically what this means is that the intercepted angles of these two chords that intersect is this one right here, ABC, and this one right here, DFG. So those are the two intercepted angles of those chords that intersect to form angles. So this intercepted arc right here and this intercepted arc right here. Well, what this is basically saying is that that creates two pairs of angles, this one and this one, which are considered vertical angles. We know that vertical angles are congruent to each other. We've looked at that before. And so basically what it's saying is that if we add the two measures of those arcs, ABC and DFG, and then multiply it by half, what we'll be able to find is the missing measure of those angles. So we'll look at an example of this. We'll look at an example of this in just a second, but here's just a little more of an overview of this. So angle formed by two chords theorem. So these two chords intersect at a point that's not on the center, as we see here. They do not make a central angle. The point of intersection is also not right on the circle. The two chords do not give us an inscribed angle. They do give us a pair of vertical angles. X and Y are the measures of the arc that intercept our two circles. So basically, whenever we have two chords intersecting inside of a circle, they don't necessarily give us a central angle, or they don't necessarily intersect directly in the center. What they do is they provide us with pairs of vertical angles. And so given that, we can use the relationship to find the missing angles. So our theorem, our angles formed by two chords theorem, basically tells us that the measure of angle 1 is equal to the measure of angle 2, where the measure of angle 2 is equal to half the first inscribed angle plus the second inscribed angle. Okay? So this is asking, what are the measures of each angle? Angle 1 and 3 are vertical angles, so they are congruent. Vertical angles are opposite angles, so that means that 3 and 1 would be our pairs of vertical angles, as well as 2 and 4 would be pairs of vertical angles. And vertical angles are congruent. That's what we know. Okay? So let's find the missing angle measure. Let's find 1. So what is the measure of angle 1? This one right here. What is the measure of angle 1? Well, basically, we would just use this equation to solve. So this would be my x, this would be my y. It's interchangeable. You can make this one x and this one y, or that one x and this one y. But basically, you want to find the measures of both of your inscribed arcs, which I did here. Now you just substitute it in. 1/2 x is 96 plus 132. Okay, 96 plus 132 is 228. 1/2, so I'm multiplying by 1/2. What that tells me is that the measure of my missing angle is 114. And because 3 is its vertical angle, it would be congruent to it. So this would also be 114. Now, how do I find the missing angles 2 and 4? How do I find that? Well, what I'll notice is that 1 and 4 form a straight angle, and 3 and 2 form a straight angle. And I know that a straight angle is equal to 180 degrees, so all I would have to do is take 180 minus 114, which gives me 66. That means this is 66, and because its vertical angle is 4, this one would also be 66. Okay. So using this theorem, we're able to find the different angle measures of these angles inside the circles. Okay, and these angles aren't necessarily central angles or inscribed angles. They're just angles inside the circle that we can solve for. Okay, any questions about this? Questions, concerns? So basically, the angle formed by two chords theorem tells us that we can use this equation right here to solve for the missing angle measure. Okay. Because the relationship between the angles inside the circle is basically 1/2 both of my arcs added together. Okay. We'll say that I'm given the angle inside the circle, but now I want to find the missing arc measure. Well, I would still use the same equation. And basically, in this instance, what I'm looking for is what is the measure of my missing arc? What is the measure of this arc right here? Arc x. Well, I'll plug in what I have. I have that my angle is equal to 92. I'm looking for x, and my y is 108. Okay, so I'm looking for that x. Okay, so I need to isolate that x. So I'll multiply by 2 on both sides to cancel out my fraction. That gives me 184 equals x plus 108. Okay, I'm isolating my x, so I'm subtracting by 108. And that tells me that x is equal to 76 degrees. So that means this missing x is equal to 76 degrees. Okay, so you can also work backwards to find the missing arc measure, right? But you're basically using the same equation. Okay, any questions about this? Questions, concerns? Okay. Now we're going to look at one more theorem for today. And this is the angle formed by secants or tangents theorem. So basically this says the measure of an angle formed by two secants two tangents to a circle or a secant and a tangent that intersect outside a circle is equal to half the distance of the measure of the arcs they intersect. Two secants intersect at a point that's outside that circle to angle 1. So basically what it's saying is whenever we have two secants or two tangents or a secant and a tangent that create an angle, this angle right here, what we can do is we can find the measure of that angle by taking this intercepted arc and this intercepted arc and subtracting it from each other. So we subtract it from each other and then we multiply by half to find the missing angle measure. That's how we get this equation right here. The measure of angle 1 is equal to 1/2 x minus y. Okay, so doing that equation, we can find the missing angle measure. Okay. And this applies for all these different types. We can have two secants, two tangents, or a secant and a tangent. Whichever one, it applies to all these different types. Okay. So let's put this to use. So basically, the equation was the measure of angle 1 is equal to 1/2 x minus y. Okay. X and y are the measures of my intercepted arcs. So this angle right here that's created, angle 25, has two intercepted arcs. This one right here and this one right here. So in this, I'm asked to find the measure of my missing arc, which is this arc right here, which I'll say is arc X. Those are interchangeable. So I'm looking for the missing arc, arc X. So I basically just plug it in. So this is 25 equals 1/2 x. I'm looking for x minus 38. Okay, same thing. I want to isolate my x to find my x. So times 2 times 2. 50 equals x minus 38 plus 38 plus 38. X is equal to 88. So this would be 88. So basically, given the relationship between, here I have two secants. Given my relationship between these two secants and the angle formed, I'm able to find my missing arc measures, or I'm able to find my missing angle measure, depending on what I'm looking for. So if I'm looking for the angle measure, I can do that using this equation. If I'm looking for the arc measure, I can also do that with this equation. Okay. So what did we learn today? We learned that the angles formed by two chords theorem, which basically says that we can find the missing arc measures or the missing angle measures whenever we have two chords that intersect each other. So basically, here we have two chords. We have chord A and E. That's a chord because it has two endpoints on opposite sides of the circle. And D and C would also be a chord because it has two sides on the opposite side of the circle. So here we have two chords. And as we can see, those two chords intersect to form vertical angle pairs. Vertical angle pairs, okay? Given that relationship, we can use the following equation to solve for the missing angle measures, given that we know the different arc measures. So if we know this, these two intercepted arc measures, we can find it using that. If we know these two intercepted arc measures, we can find it using that. Okay. So whenever we have two chords intersected in a circle, we can use this equation. We also have the angles formed by secants or tangents. And this equation is basically the measure of the angle is equal to 1/2 x minus y. So basically, if we have two secants forming a angle, two tangents forming an angle, or a secant and a tangent forming an angle, we can use the relationship of this to solve for the missing angle measures or the missing angles. So, for example, if I'm given this angle measure right here, what I could do is use the two inscribed arcs, this one and this one, label them X and Y or Y and X, and I'd be able to solve for my missing angle measure. Or if I know one of my angles and one of my arcs, I could plug those in to find my missing arc. Okay. But like always, we'll go over some practice problems tomorrow. But are there any questions about anything we've gone over today? Questions, concerns? Okay. If there's no other questions, you guys may log off, and I will see you guys tomorrow. Bye, guys.